No, I don't think it's a conflict. I think it's a co-design problem in that the software, so these patterns arise out of things that just appear in algorithms anyways. So they're going to appear in algorithms, whether or not the hardware supports them. And you can emulate all the patterns with the current feature set of processors today. But patterns are, as you're implying, they're actually a good target for optimization. Because, if a gather is an important operation in some algorithm, and you introduce hardware that makes gathers more efficient in a certain processor, that processor will be better at executing that class of algorithms that use gathers a lot. So, patterns are important because you can kind of look at a bunch of algorithms and say, okay, these algorithms use that pattern, and I think that class of algorithms is important for a certain application space, so I'm going to focus on optimizing those patterns. So patterns are a good way to sort of structure things. The other place is in design of programming languages. If you're targeting a certain application area in which a certain pattern is common, then including an explicit primitive in the programming model for that pattern makes it easier to write code for that application domain. Now, you said a rich set, and I just want to get back to that. So rich can mean lots of, or it can mean powerful, I guess. So, and actually we have, I guess there's about 16 patterns altogether. But there are actually about 8 data patterns and 8 control patterns. And these patterns, it's actually a pretty small set, and then it's actually, in some sense, and it's actually closed, in that, we sort of stopped finding new patterns that weren't just combinations of previous patterns. There might be more patterns out there. I'm not sure it's totally closed, but I think we have a pretty good handle on what the important patterns are in this space.